Now this is a special application cartridge from FiberCell. This is our catalog number C2025. We call it a polysulfone plus fiber. This fiber is specifically designed to bind proteins such as extracellular matrix onto its surface in order to enhance the growth and binding properties of cells. A specific application that this cartridge has been developed for is for the culture of endothelial cells. And in this case, we want to culture endothelial cells on the insides of the fiber. So what we've done with this particular cartridge is added a couple of three-way stopcocks to each end. And this allows us access to the insides of the fiber from the end of the cartridge, and we still have access to the outside of the fibers via the side ports. So the first step that we're going to do is, as you can see, the initial setup of this cartridge is just the same as all the other cartridges. All we need to do is aseptically attach the tubing to the reservoir bottle. And then what we need to do first is going to be to activate the fiber. And then after we've activated the fiber by running 70% ethanol over the fiber, then we're going to flush with sterile PBS and then coat with our protein coating solution. So it's all very similar in terms of how it works. We've got these three-way stopcock valves. We put the off position to the outside. We have the off position to the outside. And then all we're going to do is flush our 70% ethanol from one end of the cartridge through to the other. And if we need to, we'll flush it back and forth a couple of times. We'll make sure the fibers are nice and wetted out. And you should be able to see them wet out. Now, at this point in time, we'll want to replace the alcohol with sterile water. Is this off camera over here, I hope?
Yeah.
Good, okay. So we've gone over here, we've got our sterile water. The reason we're going to flush this with sterile water is that alcohol will cause salts to precipitate out, which we'd like to avoid. So we'll flush this again just once with some sterile distilled water, remove most of the alcohol. And once we've removed the alcohol, we'll be ready to use our protein coating solution. Now we're ready to apply our coating solution. Coating solution can be anything that would form a good substrate for cell attachment. For endothelial cells, typically, we'll look at things like fibronectin, collagen, gelatin, or mixtures of those. They all make for good formation of extracellular matrix. Of course, we can load cells on the outside of the fiber. Hepatocytes are one cell type that we've used in this cartridge. And there we would want to use other mixtures of extracellular matrix. So we're going to coat the fiber now with our protein coating solution, and typically this will be 1 milligram per mil of the protein coating protein of your choice in sterile PBS. And usually 5 to 10 mils of this solution is plenty to coat the fiber. The binding capacity of the fiber is going to be in the range of 50 to 150 micrograms of protein per square centimeter. So this cartridge will wind up binding with 70 square centimeters of surface area. It's going to wind up binding in the range of 1 to 2 milligrams total protein. So in order to coat, we go back and forth between these two syringes, our coating solution 2 or 3 times. And then we'll do a transverse application where we'll close one of the 3-way stopcocks. And we're going to flow our coating solution from this syringe over here. So force it through the fiber. And then we'll repeat in the opposite direction. Make sure that's closed. So now we close this three-way stopcock. We'll make sure this is open. And then we'll force this up through the fiber. We'll need to let this sit for 5 or 10 minutes. That's all it takes for the proteins to bind to the fiber. And then we'll be ready to start up our standard pre-culture, just with regular cell culture media like we do with the other cartridges.